Question number 2. Hydrogen gas reacts with oxygen gas to produce water vapor. So this is a combustion reaction. Combustion reactions we know are spontaneous. There's going to be a large delta H, negative, right? Combustion reactions release a lot of heat, exothermic, and then this is going to be the delta change of moles is going to be -1. 3 moles becomes 2 moles. From disorder, it becomes more ordered. Okay, so it's going to be negative, and so work is going to be done on the system, right? Because work, remember, is negative delta N RT. So positive work is work done on the system, negative work is work done by the system. So let's calculate the delta H first. Okay, so this is just like in the previous question. We're going to do the products, have positive coefficients. And so this is going to be minus 483.64. So remember that hydrogen in its standard state exists as hydrogen gas. Oxygen in its standard state exists as oxygen gas. So both of them will have 0 enthalpies of formation. So that's why we only have one value here. This is going to be kilojoules. Okay, let's calculate the change in bond energy. So change in bond energy is calculated by doing the bonds broken minus the bonds formed. So the bonds being broken are the 2 hydrogen bonds, hydrogen bonds, the O double bonded to an O, the 4 water HO bonds, right? Because 2 for water times 2, 4. This is going to give us about minus 493 kilojoules. Okay, now let's look at the change in the N. So for the gas, we said earlier that it's going to be positive 1. Negative 1, because it's 2 moles, going from 3 moles to 2 moles, so 2 minus 3 is minus 1. And then the work is going to be minus delta nRT. So this is going to be minus 1 times 8.314 number joules per mole Kelvin times 300 Kelvin. And this is going to give us about plus 2.5 kilojoules, 2,500 joules. And so we can also look at the delta N of the system. It's going to be same as the gas because there's only gas in this system. So this number will only be different when there is also like liquids or solids also in the reaction. And lastly, we want to calculate the delta S. So to calculate delta S is just looking at the table. So for water we have 188.83 minus 2 times 130.68 minus 205.14. This is going to be about minus 88 joules per Kelvin. Okay, so T delta S is equal to 300 times minus 88. This is going to give us minus 26652 joules. Okay, and so this is, we can just round it to about minus 27 kilojoules. Okay, and now we can calculate the delta G. So delta G equals delta H minus T delta S. Delta H we calculated earlier was minus 483.64. Then minus 27 That is going to give us around minus 458 kilojoules about. Okay, and so as we predicted, this is spontaneous, right? Negative is spontaneous. So this agrees with what we predicted.